And we are going.
Well, everyone, my name is Jeremy Brown, and this is my presentation on cloud device insecurity. I know that probably sounds a little ambiguous right now. Cloud's a pretty ambiguous word itself. So I'll go into more of the concepts and give you some context to the actual devices I'm talking about and some of the bugs around those. Quick agenda after the introduction. I'll look at the three. I'll tell you about the three targets that I looked at from Seagate, PDO, and Western Digital, three of the big players in the device industry. And then go into disclosure about talking to the vendors about the bugs, and some conclusion about where to go from here and how where not to go from here. Actually, so it's not a big lead way to make a change at this point. So who am I? Well, my name. I'm an independent researcher right now, consulting a little bit. Used to work at Microsoft doing Windows security. Then Malware Protection Center for a while. Also worked at Tenable. You guys may be familiar with Nessus. Did some Nessus for a while. Did some reverse engineering with patches. Writing Nessus plugins pretty much at Tenable. So what I'm not talking about, to be clear, physical device hacking. I didn't bust open devices, step the firmware from chips. It's probably possible with most of these devices, but not the area that I looked at. Also, didn't look at any of the software bundled with the devices, just strictly the devices themselves. And I'm not going to be talking about how good they were at security, or probably wouldn't be giving this talk right now. What I'm talking about is strictly the device, as I said. Looking at it from the LAN, or if it's open on the gateway, of course you can look at it from the internet, if that's the case on your network. Remote vulnerabilities and some local routes. Not that it's really that great for these devices, but remote vulnerabilities, of course, getting a shell, executing commands, those type of bugs, both AppSec and a little bit of WebSec. And bugs that are on by default, so nothing that you need to configure, nothing you need to turn on. These are automatic. When you plug in the device will be vulnerable to the bugs and attacks I'll talk about. And why should you care? You know, there's a lot of things to look at in security. The thing I came up with is I want to know how vulnerable my car is. I want to know, my router has hard-coded creds, my phone security. You might want to know what happens when you plug one of these devices into your network. Also, I found this, I don't know if anyone follows Kevin Mitnick on Twitter. Kind of funny sometimes, but one of the devices I'll be talking about, the MyCloud from Western Digital, is, I don't know if he was being sarcastic or not, but he apparently he likes this one. And I'll show you about his security in a bit. So why don't more people look at these? I actually haven't seen too many talks about looking at these type of devices. Of course, there's a lot of talks about looking at physical devices, but these in particular, they do require a small investment. Of course, any consumer product you're going to have to buy or borrow or steal, probably shouldn't steal it, but acquire it in some way in order to look at it, because not all of them are virtual, or you can't usually get a virtual version of them. So you can't go to a website and just start looking at it. You can't download a demo of these because they're physical devices, of course. And if you look at any electronic consumer website that sells things, Amazon I use in this particular example, this has nothing to do with Amazon Web Services, anything like that, or their cloud services. This is just what types of things that they sell through there. And there's a ton of different brands, a ton of different of these devices out there. If you just search for cloud under like the data storage category. So it's very prevalent. But there's a few different types of cloud devices, or cloud concepts in general. The one I'll be talking about, like AWS, for example, fits in the first one, the online clouds. But I'll be talking about the NOS devices. So a cloud NOS, you should kind of call it, is like a network-attached storage, so a hard drive that has a network capability, or you just plug a hard drive in the computer and hit share, but it has a chip, it has memory, it has an operating system that provides all these different features that normally you'd have to do separately. So that's what I'm talking about. If you can envision a box, a hard drive, and operating system running it, you plug it into your network, this is the cloud device that I'm going to be talking about. So let's get into the targets. First one is Seagate. So first, when we go through the biggest, the most popular devices I found from the vendors, MyCloud from Western Digital. Some of you may have heard of it. It's probably by far the most popular one. Also, Akidio makes one called the MyCloud Together. That was, I don't know how that wasn't like a trademark issue, but they worked it out. And also the Seagate Central. So Seagate Central is the popular one from Seagate. And when the marketing team talks about this, of course, they're going to be like, yeah, your data is always safe and under control. Just kind of pointing finger to look at all the stuff they say about it. This is what they're supposed to say. But they're definitely nowhere near what we're describing from a security standpoint. So let's look at the Seagate Central first. This is the model I bought, I acquired, I looked at, and the one I'll be telling you about the security aspects of the device. So as soon as you plug it in, if you do a port scan or look at the networking on it, there are 12 well-known open ports. These are a few of them. It's got the biggest ones, FTP, SSH. It's got a web server running. It's got Samba file sharing running. So you definitely see it's pretty juicy at this point. Like, wow, you have some pretty hardcore services running. And when you remote shell into the device, you don't even need, so the user that it comes with automatically has C privileges. So you can escalate to root without even needing to know any other passwords. So at this point, local attacks aren't even necessary. It also runs this strange Linux distribution, and a lot of Linux distributions. This one has this interesting haiku about it. I'll share it. Maximum to minimum, agile, stable, open yet not secure. So if there's no root password, so you can just log in as root remotely, right? Well, if you've ever tried to do that, you probably can't. Usually the configuration file for remote shell daemon doesn't allow you to do that. It doesn't allow passwordless root logins. But remember, we have FTP there, so could we perhaps log in as root through FTP? And even if we can, which we can, they don't really give us a remote shell, and that's kind of the target at this point. But we call it a break because the web server that the device is running as root. So we can log in the device using the root account, no password, upload a PHP script, which allows us to pass commands through it. And then when we access it through the website, it's running as root anyways. So at that point, we have a remote root on the device already, just by using passwordless login, and because they're running the web server as root, which is horrible design in the first place. So there's remote root on the Seagate device, just off the bat. Also, it has Facebook integration with this. So that was interesting to me. Is like, how does it do this? How does it store the credentials? Because it has to do it some way. When you log in, it's going to have a token. It's going to store your credentials somewhere on the device, because that's how it works. So that's what I really wanted to look at too. And I found that it stores the data for Facebook, for example, and other social media accounts and it's world readable too. So that's another mistake they made. You shouldn't. At this point, there's no real privilege separation, but you definitely shouldn't make it world readable, because anyone logging into the device, root or not, can take your access token. And the token is used when you log in. It'll create a token which usually expires at a certain time, and the app can use that to log into your account and communicate rather than storing credentials. So it does that a little bit better than it doesn't store your plaintext credentials, but still, if you steal the token, you can impersonate the user. And that's what we did. So we have the token, and we can log in, and this is the page showing the scopes of privileges we have by using that token. So we can look at the, of course, public profile. We can look at the photos, videos, and the friends at that point. We have a little bit of access. So once we have a remote root on the device, we can steal the token file, or the Facebook configuration file that it uses for social media accounts, and impersonate the user. So it's even more of an effect than getting control of the device. You actually have control of the data, including if they put their social media accounts on the device. And this was an example of an exploit I wrote for that. You can, once you get the file, you take the token and use the token, and using some of the Facebook APIs in Python. You can use that token to get the friend list, get other things. And this is just returning, for example, its list of friends, which of course is usually private, depending on your configuration profile. And that's how I felt after doing that. There's also some other things with the device, minor bugs, or minor interesting things with relevance to security. There's some unprotected web resources, so some XML files that contain, I don't think these are actually used with the device, but maybe there's some internal usage of this. But if you can read a little bit, it says like username is admin, password is admin. Some of these things just should not be accessible without logging into the device in the first place. So this, I don't think that was actually the username and password of this device. It was just something that they ended up not protecting, which looks pretty sensitive at this point. And just leaving collateral around, and this is more just grepping on the file system, looking for more internal passwords that they used during development phase, probably before they shipped the device. So just leaving test collateral, leaving unprotected resources lying around, shipping the device to potentially millions, thousands, millions, hundreds of customers, and somebody looks at it, you're able to see what they didn't delete before shipping. There's also one of the, for the network services, there's a Seagate WSD daemon. I'm not going to go into what it is, but it takes SOAP requests, and so you can access it, you can connect to it, send it SOAP requests, it'll send different things, and I was fuzzing the SOAP request a little bit and found just a trivial malformed SOAP message will crash your entire daemon. So just very, very fragile on the custom services that Seagate provides as well. And also, this device had a remote access feature. And this was, of course, sounds interesting. So I definitely wanted to look at it and see how it worked a little bit, see if there's any bugs in that. Because that would be very, very cool to look at. So the way it provides it, there's an agent called Tap-in Agent. And Tap-in Agent allows you to tap into the device, well named, and it allows you to remotely, so you connect to Seagate's website connects to your device, and there's kind of a funnel of connection at that point. So if you look at the client, it's actually written in managed code, it's written in C#, and they use Mono to run this on Linux. And that was just another interesting design thing that they did, is why you can just rewrite it in native code or make it a script or something, but they literally just like, nope, going to use managed code, just going to use Mono to run it on a Linux box. So this was a fail story. I want to give you a little bit of perspective of what I did to it and how actually I didn't exploit the service. But in some cases we get a remote shell, but they really need to screw some things up, and that didn't happen at the point. But first of all, you have to guess the login credentials, which may not be that hard. But once you do that, you need to create a symbolic link to somewhere useful. And that was kind of a restriction they put on when I was looking at the device. I saw that I couldn't really create anything that would make it would make this a fully automatic exploit remotely. But I did see that you can browse around. When you log in as admin remotely on the device, you can browse with root privileges. So that was like an auto elevation I didn't really expect. So at least if you're able to guess your credentials, you basically have root on the device because of that. So the technique I tried to like backdoor the startup script. So I tried to create a symbolic link to a file that I controlled that would then allow me to modify the startup script of the device, which didn't end up happening because they run it as the user instead of root. So I couldn't. I was trying to get a remote shell by backdooring a startup script, but I wasn't able to because they used a different user to start this particular script. But still, it's good to learn from failures like that, so that's why I want to share that story. Also, they run a media server through Django. I don't know if you ever heard of Django. It's a media server for the web content. But they put the secret key. If you have access to the device and they ship this, I'm pretty sure they don't randomly generate this on everyone. This is a static secret key on every device. And, okay, so you're like, okay, if you have the secret key, what can you do with that with Django? Well, there's a bunch of different things that it uses it for. So it uses for salting HMACs, so salting some cryptographic functions to to ensure that it hasn't been tampered with. It uses for the reset token. So if you're able to get the secret key, which as far as I can tell is statically shipped with every device, all you have to do is get access to one device. You can own all of them in that respect. Then you can tamper with all these security features that Django provides. That was another failure from Seagate, statically embedding that into every device. So, pen tester cheat sheet I want to give you for this. If you find this a Seagate Central on the network, definitely have quotable storage. And it comes default with just open storage on the device. Anytime you get user credentials, you know, like to root, either remotely through the tap-in agent or just logging in locally on the LAN. And also FTP for root. You guys saw I uploaded a PHP script, web service running as root, the remote root on the device from there. And you can look at their social media accounts if they store any on the device. So, next target, the Kedio MyCloud Mini. This one was interesting on the first time I looked at it. Telnet is open as soon as we look at the device. So run port scan, see Telnet's open, connect to the device via Telnet, and you know it's going to be a short day because if you're running Telnet, you probably don't care about a lot of other security things. So also they're running Fedora version 12, which, and I'll actually look this up, is very old. I've run Fedora on my main box. I'm running like 21, 22 at this point, but 12 is not 21 or 22 if you can count. It's super old, and that comes with a lot of definitely at least kernel vulnerabilities and probably a lot of other local attacks as well. But we didn't need all that because after I found out that we couldn't get root automatically like we do on Seagate, I wanted to look for other SUID binaries laying around. Anything else on the file system that would potentially be vulnerable and allow me to have access and escalate to root. And I found a couple. They were Python. They SUID rooted the Python binaries. I don't know why. I have no idea why that was a thing, but they did. So you don't really need much of an exploit for that. You just, if you have a SUID root Python binary, just write a script that just says, all right, set my UID to 0, set my GID to 0, and execute a shell. And you have root after that because you're already executing the code as root privileges. All you have to do is ask for them. So we have a local root on the Kedio. And there's kind of an update issue as well I found with mine. I was trying to look at the updates that were available, and it said a new one was available. And then I looked at my device, and it wasn't showing anything new. So I'm not sure if they had a bug in the update system at that point when I was looking at it. But there was something funky going on. So even if they release security updates, you may not be able to get them for some reason on their backend. And also on the Kedio device, it runs TR069. Some of you may have heard of it. It's a crazy bad management protocol that has started being implemented on a lot of different Internet of Things devices. And it's really insecure. It's really, I mean, you can look more up about it later if you want, but it's just super. A lot of times ISPs use it to remotely configure a device, and it has little to no security principles whatsoever. And anything running this can be totally owned. And I'll show you. Well, you can't see it very well, but this is me running the TRS client on the console, so you can see the debug messages, and you can see the communication and talking back and forth with the vendor's domain, trying to like pings and heartbeats and things like that, and perhaps even updates and other control measures they use. So a lot of this work's already been done on TR069, the implementation and the way that it runs on these devices. If you look up a talk, it's a really good talk called Too Many Cooks. If you just Google for that, it'll look at, it's called Too Many Cooks Exploiting the Internet of TR069 Things. And that'll explain just how bad this protocol is. But this device runs it, and so that's why it's relevant in this case. But the good news is you can turn it off. Once you root the device, you literally need to root the device first. I'm pretty sure that the service is running its root. And just do a kill log to NOS, that's TR, that's the process that implements it. And you can make your device a little more secure at that point. And some other collateral I found laying on the system. Apparently they contacted someone personally to write some of the scripts. As you can see, I blotted out his name and stuff, but they left his name, his personal email address on the files that are shipping to all these customers. And it's not even from a company, it's just at gmail.com. So you see the professional quality that goes into writing a lot of code for these devices too. So at that point, here's where we are. A lot of cloud, a lot of modern, not very security. But the finale for this device, and the thing that really rolled them all for me was they left a couple other test scripts in the web root for this device. So they left test.html and test.javascript. And if you go to test.html, it gives you, and what it looks like if you would remote shell into it, they black screened it all. This was super good testing collateral, but they left it on the device. You get a command prompt. That's awesome. Look at the command prompt. If you type help, you get a variety of options. You have like things like get the MAC address, get the turn the LEDs on and off, do stuff with the buttons, clock. Not really worried about all that. I keep looking at key, and key, is described as get secret key. That sounds good. I'll get the secret key. I don't know what it does yet, but I definitely want to see that. So we type key, return secret key equals this. If we look, and I know you can't read this, but if we look at the implementation of secret key, it's stored on the flash. So at a certain offset, it's like this calculation offset at a certain location in the flash stores the secret key. And this is going to be on all devices. So again, another bug that pulls them all, because it's not generated on demand. It's stored in a specific location. So I was kind of curious because I couldn't really figure out, I spent a lot of time looking on the device, seeing what would use the secret key. And I just kept spending time on, okay, why don't I just ask the vendor? I'm going to report these bugs. I want to tell them about this, crazy test collateral they accidentally shipped on the device. But I really want to know what secret key does. But I can't just keep hammering away and not getting anywhere. So I asked them. And the reply was the secret key is used for remote assistance service. And that was, it made sense at first, but it also was kind of weird because I'm thinking, okay, what remote assistance service? I looked at all the networking services on this device. I didn't see any crazy ports being opened and a service running on that port that would accept something like this. So I kept asking, and they just kept giving me these BS answers, going around the question. And after a very long support thread over, pretty sure it took weeks at this point, because each reply was like 3 or 4 days at a time. They finally told me, I understand your concerns, but I'm not at liberty to disclose details about the secret key. So you can read the, well, no, you can't. You'll not be able to read that. The pastebin thing, it'll show you the full conversation, which went along over days. But basically, they gave me the run around about the secret key, and it must be important at this point. So, pen tester's cheat sheet. Look at HTML or look at test.html. That will give you a lot of nice things. Give you a command prompt in a web browser, which is always nice. User access equals root access because they sudo rooted the Python binary. So I haven't got an answer for why that was the decision to make. And if you watch the TR69 videos, I know that's a weird protocol name. But if you go watch these videos, you'll be like, wow, that's crazy. So, final target, the Western Digital MyCloud. This is, like I said before, this is probably the most popular one. And it's debatable, but it may be also the most insecure device. So they actually have these commercials. I didn't see this till I came across on YouTube. They have these overclouded commercials. And if you go look them up, they're pretty comical. But they portray the cloud hacker as this guy, your standard Eastern European guy with a outdated jacket. And that's how you hack, apparently. You look over someone's shoulder, see what they're doing. He could have just been stretching. I don't see the connection there. But they really promote this thing, they really promote security for this device. But what I found out when I plugged it in, it has a very interesting design choice, and it's called auto authentication. By default, there is no authentication. There's nothing you need to do. They've already done that for you. When you log in, you can see the pages switch to each one, to like the next session login. And it's logging in, but you don't have to do anything. So I'm not sure if they're using a default password, or I can't remember what they're doing with this device. But anyways, by default, there is no authentication. It's already done for you, and that invalidates a lot of assumptions that the other party is making. When they're saying, okay, only administrator can do this or that. Well, if you're auto logging in, you're always going to be administrator. So you just kill all those features and all those assumptions we're making for the secrets to only be that would be secure if you were to actually log in traditionally. So I'll get back to that, but I want to go on Twonky for a minute. Twonky is the media server that it runs, and there's also no authentication on this. It's not auto authentication. There's just literally no authentication. There's no password by default. So you can play with various things on that. Gives you a little bit of control. If you look at the Twonky server and you grep for RPC functions, there's a ton of things you can send to it, and it's really easy to write exploit for this. Restart, you can rebuild, you can reset the clients. You have full control of the Twonky server using its API, which is basically sending web requests for the most part. And there's like 99 different commands you can issue. And there's around 150 different configurations that you can change for Twonky as well. So, point being, you have full control over the media server at this point, as well as the web interface. And this is just like kind of a useless bug, but I wanted to show it as well. It's not really it's like a half fail, I guess you'd say. You can create a file on the main file system with Twonky, but you can't control the contents, and it won't override an existing one. So if it could override an existing one, that would be more interesting. But you can't create it, and this is like unpatched bug, whatever it is. Not very interesting, but I'll just tell you about it real quick. Also, this is another thing I tried on this. I was trying to do some command injection because I saw that every time you put new media on the server, like logically when you think about it, when you put new files on there, it's going to have to rebuild the database. So otherwise, it's not going to be able to show you on the web interface all the new songs that you put on there, all the new pictures, unless it knows about them. So it's going to have to do this either on demand, like you click rebuild database, or it's going to do it every 5 minutes, every 10 minutes on a timer. So for this one in particular, when it rebuilds the database, it passes a lot of the commands, because if you put MP3s, maybe it wants to convert it to like AAC or some other format. So that's why it rescans it, and each file name it takes and it puts in a command line parameter. So first thought there is, okay, can I inject command lines? Well, I tried that, and I got very, very close, but it's actually sanitizing a lot of input on that part. So I feel like they had some kind of internal pen test, and they're like, you really can't do this. This is very, very bad. Because that would have been another remote device. Because by default, all of the shares are open anyway, so you don't need to log in to access the shares. So anyone could drop a file in and rename it some command injection, and when it rebuilds the database, it would execute that command. But it didn't work. Very, very close, but it didn't work. So at that point, I kind of switched the way I was thinking. Because I knew that it was auto-authentication. I knew that I didn't need to log in, but I also knew there was a lot of things that were privileged commands that were happening through the web interface. So one of them was update firmware. Now I know that you can just package up firmware, backdoor it, fix all the checksums and stuff and put it on there, but I knew that was kind of easy. I didn't want to really take that route. I wanted to see, is there any other things that can work in this way? So I tried to just give it so it accepts accepts the firmware image, but a particular format. I didn't know what the format was. So I gave it a random file. I tried to upload a random file with firmware, and it came back, please select the .dev file. Okay, so at that point I know Debian-based Linux distribution, it uses dpackage for the manager, I'm going to have to give it a dev file format, or at least with that extension. So I give it that. I literally downloaded a argtables to .dev file. Gave it that to see what happened. Now it gives me invalid firmware image. Okay, well, maybe I can't just give it any file, but I'm getting closer to something here. There must be some sanity checks on this. So I just renamed the file. I'm like, well, maybe they're passing it to D package without sanitizing. So I just renamed it, insert some meta characters, and I can see through the shell I have on the box. If I do a PS and I look for the function the script that's running to do this, I can see that it's doing a sudo to run this command. So it's escalating privileges to root to run this command. And that's very interesting because I can see there's command injection. So now I can use that to my advantage. I can just say, I'm just going to rename it, hey, escalate my privileges to run this command. And that's what I did. So I don't need to upload a backdoor firmware image. All I have to do is upload a file, tell it to escalate privileges, and give it my command, and it'll do that. So that was a whole thing around. I don't need to backdoor anything, don't have to worry about all those checks. I can do it just by renaming the file. And it uses, it escalates to root a whopping 283 times. 283 times I found an execute runtime function call that involved sudo command. So all these, that's 283 chances, if you're able to control some, the input, to potentially inject commands as root. And you can do it through device.php, which is another file. And if you give a configuration file with a device description of, again, just put some meta characters in there and give it a command, and you try to upload that configuration file to device.php, another root. So because the auto authentication gave me access to privileges, or give me access to privileged commands that only an administrator would normally have, I don't even need a shell at this point. I can just use the web interface to execute commands. So, and you can really see the divide here between the two development, maybe the feature teams, I imagine, at Western Digital. Because one, even in this file, they talk about, this parse security, I don't know what that means, but security requires a min authentication and request allowed in LAN only. I don't think they actually enforce this to LAN only. I don't know how they can, really, on that, and not a good way if they want to do that anyways. But the requires a min authentication, you can see the separation between, okay, you have this one team working on the web UI, and they're like, all right, we can do all these things because they have to be authenticated as administrator to perform. And you have other teams like, man, this device is really hard for anyone to change the configuration. I wish there was just a way that we would just never have to log. Oh, we would just never make them log in. And that creates a conundrum for Western Digital, because now all these commands security can never be enforced because you never have to log in. So, if you haven't got the picture from now, there are plenty of remote root options through the web UI. Infinity, T-wonky commands if you want to try that route. And auto authentication really ruined this device. And even worse news, there are no, and correct me if I'm wrong, it's been a couple months since I looked, but there's no security there's no secure email addresses for any of these companies. There's community forums, but they're practically worthless. If you tell somebody about a problem, or if you ask them how you can get in contact with product security, they just say open a support ticket. I've never saw an advisory from any of these vendors. There's release notes, but it's not advisory. It's not telling anyone anything but customers that have to log in and go through all these hoops just to see, and they're barely notified of these issues. And they honestly don't care about security. That's the bottom line. So disclosure. So now that you're well aware of all these shortcomings, you can imagine that it may be interesting to talk to the vendors about these because they're already on the bandwagon, right? So it's kind of what it felt like. Went to a lot of different places to get to these vendors. And with Seagate, so I reported on the 27th of January. The first response was they told me, don't worry, these devices aren't affected by shell shock. I did not mention shell shock at all in my email. this has nothing to do with shell shock. So that's what I told them. And I'm like, all right, give me somebody else to talk to. I can't do this. And eventually, they told me an update has been released, which, as I said before, that there's no advisory. It's just there's an update and there's a little mention of security, and they love the shell shock vulnerability. That's all they mentioned. It's like, oh, we're safe against shell shock. For Akitio, they were actually pretty fast. They just were horrible to talk to. They, as mentioned earlier in the real talk section, those, I still would like to know what secret key affects. I'm pretty sure it's important, but it just did not take. I spent like 4 or 5 days on each of these devices that other projects I want to work on. So, if I had more time, I would definitely want to look into that. But hopefully, you guys can do that if you're motivated enough from this talk. And for Western Digital, well, they just took the easy route. They just didn't respond at all. So after 4 or 5 months or so, even CERT was super unhelpful in this. I'm sure they do a lot of good things, but they did not help me with this very much. And no response from Western Digital, so I just disclosed it in May. And the devices probably still aren't patched, I imagine. And what was funny, when I was on the Western Digital forums I mentioned this earlier about trying to talk to somebody or get in touch with somebody about security through Western Digital. And if you're in Western Digital, if anyone here from Western Digital, any of these companies, I'd love to talk to you. You probably don't want to talk to me right now after this presentation. At some point. It was really funny because all the people that I was like, hey, I have these security issues, I really want to talk to somebody. Can anyone help me here? All that. And the responses from either customers or maybe they were trolls, I don't know. They seemed like legit people. They were just fed up with Western Digital. The responses were just hilarious. They were, like, one was like, I was like, hey, I'm going to disclose these bugs eventually if no one can help me fix them. And one of the responses was, I look forward to the disclosure. Just like a normal person, I'm pretty sure. They were just like, hey, I can't wait to see these. And then some people were like, I've seen other posts not taking a big chance, or Western Digital's not taking the message. Just people were just tired of the security issues with these devices, and that was quite a loop when I looked at all the quotes from this. So the conclusion, as you can imagine, it's not bright. Yeah, it is all doom and gloom. If you've been paying attention at all, this is marketing security is probably pretty low on the list of how they work. Expectations, as you can see, if you plug any of these devices into your network, expect anyone to have root, anyone to compromise the device. And you're going to at least be like an old school where it's FTP pub for someone at least. Some of the solutions I was thinking about, there's not a whole lot of good ones here, but option one may be, I know a lot of people install FreeNAS on these devices, so perhaps if you're able to do that after you root it and install a totally different operating system than what it's running, that would help a lot for security. Or option just don't buy devices. I mean, it's ridiculously bad. You haven't noticed. There's not a single security principle in practice during any phase of the manufacturing or development on these devices. If you want security, I guess talk to the vendors. I don't know if you stop giving them money, maybe they'll get the picture, or if you just keep complaining. I don't know. The trending strategy at this point is just there's no email address. You literally have to either open a support ticket or you have to beg on the forums. You have to do something. They just route everything into this big hole in the ground, but they never have to look at it. That's my experience, at least. Or, actually, this is one strategy I did, was spend all day on LinkedIn looking for people that worked in security or just people from that company, send them a whole bunch of emails and be like, hey, I got this really bad security issue, can you guys help me with this? And that worked a lot of time, but it took a lot of time, a lot of emails, and a lot of just nonsense. It actually works if you ever want to try that. So, conclusion, don't trust personal thought. I have to say that. There are no securable objects if you think in the security principle, Salter and Schroeder mindset. Kind of general, it's just marking a line. I mean, honestly, some of you probably don't agree. Again, fine for secrets, but fine for non-secrets. If you don't value integrity, not okay for secrets because they're not going to be secret anymore. It's going to compromise it. The company is going to use it to market stuff to you. Whatever. I don't believe in it. Don't like it. Got a lot of stuff to do in this area. And before I ask for questions, I want to engage you a little bit. I want to actually show you that whoever, and I've decided this is pretty unfair, but whoever asks the best question will get this crazy bad Seagate device. This is the actual device that I broke. And it is not, if you ask me, it's not backdoored. There's nothing wrong with it. I'm pretty sure I reset it to factory. So if you're good at forensics, maybe you can go look at my old exploits on it. I don't know. But brand new, pretty much brand new device. I just take the plastic off. So best question gets this device. So ask your questions. One question.
Sure. I use and sell Synology, which sounds as a comparable NAS device. I know, I was curious, the first thing you usually do with those devices is go through, they have like a discovery program, and then you set your username and your password. If you go through their wizards and then put in your username and your password, do your exploits still work?
So I did not.
It sounds like when you did it, it was almost like you just plugged it in, right? In an auto discovery. But
yeah,
I do that, and then go through their wizard and do it. Will those type of exploits still work?
I have not verified that using the software included. I'm not sure if all these actually included a disk or something like that. Maybe there's some configuration program for that, but I can't, because I didn't use the software. I can't confirm that would be the case. I know it probably is for some other devices. I don't know, like especially the auto authentication one. I'm not sure they're going to, because when you plug in a device, there is a wizard that pops up.
Right, like a configuration.
So for that, yes, sure. For that example, sorry, I took the question too literally. For that example, no. If there's, I think maybe one of the devices it says it gives you an option to, but the other two it doesn't at all. It doesn't ask you to set one. It doesn't say anything about password. So I didn't use the software again, but just plugging in and going through the initial configuration wizard, which is, I would guess, the easiest way to look at this device without having to install some stuff. If you just go to the web page and set it up, there was nothing. There was nothing asking you to set one. I don't think there was a way to set one until on the Western Digital one. You literally, I had to go through the documentation to figure out how to set a password. There was some crazy option of like administrator, and you go through other options, and it's like, you can set a password here. It's a little tiny button. I mean, that was the case for at least the Western Digital, and the other ones, it was not on the configuration, though, to answer your question.
I have two questions.
Sure.
So
Four questions.
Yeah, two questions.
Oh, two questions, okay.
The first question is, I know you try to access these individual cloud devices. Rather, have you tried to go to their main cloud storage to see what are the vulnerabilities exist? Then have you brought them to their attention? Second one is, what is the intention for you to test on these individual cloud devices to see what are the vulnerabilities exist? Is this for just to tell them that, okay, this is the vulnerability, so you go and fix it, or what is the intention for this?
Okay. First question, have I looked at any of if the vendors have the cloud services online, have I pen tested any of those? Answer is no, I have not. Maybe that work for the company, or they contracted me to do that work. I may take them up on it, but no, I haven't looked at that area. This is strictly just the physical devices, not the online cloud devices. Second question, my motivation or the reason I did this, I saw these as a new up-and-coming device, and I knew that it would be, the security for these weren't there. I knew it wasn't there. I didn't have a way to prove it. And so I made the investment and did the research to do it. So for me, it was just more of, I know there's a lot of bugs here. By nature, I like finding bugs. I like writing exploits. So that was just fun for me to do, and also my ability to take that research and then put it into a talk that I can share with everyone else, and engage on questions and things. That was the motivation for me to share the research with everyone and to help beat down the marketing lies. This stuff is secure, because it's far from it. Good questions. I'm not sure who was first. I was looking up here the whole time.
I was surprised at the number of vendors on Amazon that marketed these devices.
Yeah.
I checked a couple of years ago. And the big players were Drobo and File Transporter. Okay. I'm just curious what maybe you told us your method of selecting these products.
I think it was more of the method of selecting the products. I'm trying to think. It's been a few months since I selected the products. But I think it was, I got sorted, literally on Amazon, I got sorted by most reviews or most popular ones, whatever the option is. And I found like the top, out of like 5, these were the ones that looked the most interesting to me. And based upon the models, I didn't want to buy like the 20 terabyte one, plus it probably has the same stuff as the 10 terabyte one or the 3 terabyte one. Usually, there's some other professional suites that have those, but answer your question, I'm mostly just sorted by the ones that I saw that looked the most popular, that were being bought by consumers, that would affect the most people. But good question. Sorry. I don't know which one's first.
Kind of based off that,
okay.
I went with Western Digital and Seagate, and I do purchases kind of sort of for the Army, but we go kind of seem consistent. I won't say the name brand. Consistency with hard drive failure, and you went based off security. But with that being said, you guys, with hard drive failures, with the Seagate versus the Western Digital, and with the security, do you see failures as well? Because, I mean, there's one of them up there, I'm not going to say which one, but we have a lot of hard drive failures on one of those name brands over the other name brand.
Okay.
Do you see that?
All right, so the question is, have I saw any hard drive failures?
Well, because one of the name brands up there, we have a lot of failures. I mean, we buy bulk. I mean, thousands of bulk or not. And one of them up there tends to be a lot more failures.
I didn't look at that.
With the clouds, because obviously, you know, clouding them. So one of those up there, consistently, we buy thousands of, and consistently tend to be failures.
Yeah. I didn't look at the physical security aspect of that part, the failures.
Did you look at that?
I didn't look at the failures part, sorry.
Okay, just security.
Just the, you know, if I can get a shell on the device, if I can compromise the device, not actually the failure mode or the recovery of the.
I'm just kind of curious to see like longevity on that kind of thing. You went with the security side, are you wondering if longevity, one lasts a year, one lasts 5 years, because consistency. Looking at Fort Knox, we have a lot of one lasts a year, one of them lasts 5 years, and consistency.
Yeah, that would be interesting to look at the longevity.
One of them doesn't make it long at all.
Cool, thank you. Good question.
Any chance you want to develop a network scanning tool to identify
I think that
boxes?
Yeah, I think that a lot of this can be automated. Like I mentioned, this work for Tenable, and so Nessus is a really is one of the automated tools that could identify all of these. So I don't plan on writing a tool myself to do this. I think that I expect there will be some probably Nessus plugins or whatever product plugins to identify these with all the network scanners out there. But no, I don't have any plans to develop my own tool for that. But it's pretty straightforward, as you can see, to look for these vulnerabilities and to scan for them too. I welcome any questions in regards to developing stuff like that.
If you buy the Seagate or Western Digital, could you just wipe the machine or wipe the drive first? Like write back to ones and zeros and then use it with that?
So yeah, one of the solutions I mentioned was installing another operating system on it, like FreeNOS. So FreeNOS is something you can use. It's kind of like a vanilla generic operating system you can use for a lot of embedded devices, and which contains NOS features. So it can be like a replacement for the operating system that they run by default. So that would be my recommendation for that. Yes.
So you're arguing that these are not secure devices from a cloud standpoint. Right? So if you expose it to the internet, there are holes in it and could be compromised. But if you use it internally, not expose it to the internet, and not it behind a firewall, your risk drastically will drop, wouldn't it?
Of course, if you put up a wall around your house, there's going to be a lot less people parking there, right?
No, but my point is that your approach is that when you expose this to the internet, this hole is huge.
If you expose it to the internet, yes. So it all depends on your network configuration. Obviously, by default, your router probably won't expose this to the internet unless maybe with bundling software, maybe it opens up on your router. I didn't look into that. But even on internal pen tests, so a lot of these, I think like it being critical. For example, if you're at a company, you're working at a company, you have one of these devices plugged in, and you're using it to share files with your coworkers or something. If someone does an internal pen test, or just someone on in the company wants to compromise the device, it's going to be open at that point. Depending on the network configuration, it is. But it is a good point. These aren't open to the internet by default, so that does mitigate your risk a little bit, usually, depending on your network configuration. They totally could be open. It just depends on you plug it in, and your router or your firewall decides who can get in, who can get out to what. So, question? Yes.
Did you happen to see if they were running vulnerable versions of Samba?
I'm pretty sure that all the ones when I paid attention to it were running older versions. So I would, and there's been at least one or two Samba, good Samba bugs in the last couple of years. So I would say they would be running vulnerable versions to those bugs. There's been one in the last 6 months that was pretty serious, I think.
Yeah.
So they were all running old versions, long story short. Yeah. Any other questions? No one else want to put in? I don't know who's winning so far. This guy's pretty good. He asked 2 questions. Real smart. You doubled your chances on that, I think. Well, maybe 1.5. Better. We could have a question off. I think I get a few. They were good. They were both good questions too. So you were a close second though. I like your question. And all of you had good questions. I'm sorry. Can't be totally fair here. Oh, sorry. You have one more question?
Yeah.
You want to get on this? Let's do it. Okay.
It's apparently not very good.
Hey, there's 6 terabytes of storage on this, though. You can put it in your computer.
If you had updated the door,
Mm-hmm.
bringing it up from 6 years ago to now, could you, would that have fixed some of your problems?
Well, that's one thing I mentioned to them too when I was talking to Akio was your kernel's crazy out of date. Like you need to update the distribution you're running Fedora 12. And because there were other local vulnerabilities, I could have used some other exploits to do the kernel and escalate privileges, but I wasn't looking at that. I wasn't looking at public ones. I wanted to find new bugs. But yeah, if they would upgrade that, or if you could do that, that would definitely improve a lot of things.
I was just curious how many of the vulnerabilities were related to the out of date.
No, so all the things I showed you were not public. They weren't public before I found them, at least. But another thing I did mention to them too, I said, hey, you guys are running Telnet. You should run SSH name. It's installed on the box. SSH is installed. It's just not turned on. And they said, okay, in future releases we'll look at turning off Telnet and putting on SSH. I'm like, it's on the box. You're just not using it. I think I literally turned it on. Like, I don't want to use Telnet anymore. I want to use SSH to continue my research. But,
can they use Fedora on a commercially sold product? Does that violate the GPL?
I don't think.
I don't know about
Yeah, that's a
the
licensing
agreement Fedora's under, but
yeah, maybe if they usually there's like a document you put.
Fedora Red Hat's cousin, right?
Well, Red Hat's a little different though because they're very enterprise these days.
Oh, I know. But
Fedora's a little open.
Who backs Fedora? Is it Red Hat?
It used to be. I'm not sure if they still do or not.
The project from Red Hat, right?
Yeah, maybe they're usually
So
there's a
they're
license
circumventing-
file and stuff there. So yeah, I'm not sure. I didn't look at the
I think
license
they got a
issues.
real legal problem there, maybe.
They very well could. Well, thank you very much, everyone. Appreciate your time.
Oh, yeah.
Thank you.